Understanding the limitations of visual color indicators in pH determination. Title: Understanding the limitations of visual color indicators in pH determination. Introduction. pH determination, the measurement of acidity or alkalinity, is an essential aspect of scientific research and various industrial processes. One of the most commonly used methods for pH determination is the visual observation of color changes using pH indicators. These indicators offer a quick and cost-effective way to estimate pH levels based on observed color changes. However, it is important to understand the limitations of these indicators to ensure accurate and reliable results. This article aims to shed light on the constraints of visual color indicators in pH determination. The basics of pH indicators. pH indicators are chemical compounds that undergo specific color changes as the pH of a solution changes. They are typically weak acids or bases that exhibit different colors in their protonated, ACI, DIC, and deprotonated, basic, forms. The color change occurs due to the variation in the electronic structure of the molecule as hydrogen ions, H+, are gained or lost. Common examples of pH indicator include phenolphthalein, bromothymol blue, litmus paper, and universal indicator. Advantages of visual color indicators. Visual color indicators offer several advantages in pH determination. Firstly, they are relatively inexpensive and readily available in the market. Their widespread use has made them easily accessible. In various forms, such as solutions, papers, or strips. Additionally, most pH indicators can be used without the need for sophisticated laboratory equipment, making them suitable for fieldwork or educational purposes. Furthermore, pH indicators provide a visual indication of pH levels, making them intuitive and straightforward for users to interpret. This makes them user-friendly for those without extensive scientific knowledge. They are an excellent tool for quick estimations or preliminary assessments before employing more accurate and precise methods, such as pH meters. Limitations of visual color indicators. While visual color indicators serve as a valuable tool in pH determination, it is crucial to be aware of their limitations. These limitations stem from factors such as sensitivity, accuracy, and subjectivity, which can influence the reliability of the results obtained. 1. Sensitivity. The sensitivity of visual color indicators is one of their major limitations. Different indicators have distinct pH ranges over which they undergo color changes. Therefore, the accuracy of indicators is limited by their inability to detect subtle pH variations. For instance, some indicators have a narrow range and may only be suitable for a specific pH window, while others may provide a broader range but with less precision. Additionally, the color transitions of indicators can sometimes be ambiguous, resulting in difficulties in interpreting pH values accurately. Determining the endpoint, where the observed color correlates precisely with the corresponding pH value, can be subjective and prone to individual variations in perception. 2. Accuracy and precision. Visual color indicators are often not as accurate or precise as digital pH meters. These indicators rely on human observation and judgment, which can introduce human error and subjective interpretation. Factors such as lighting conditions, background colors, and variations in observer perception can adversely affect the accuracy and reproducibility of pH determinations. Furthermore, the accuracy of visual color indicators can deteriorate over time due to degradation, contamination, or exposure to environmental factors. This degradation can lead to a mismatch between the observed color and the actual pH value. Therefore, Regular calibration and quality control checks are necessary to maintain accuracy. 3. Interference and selectivity. Visual color indicators can be affected by interferences from other substances present in the solution being tested. These interferences can result in color changes that are unrelated to the pH value, leading to inaccurate readings. For instance, the presence of strong acids or bases, colored compounds, or high ionic strength solutions can alter the color transitions of certain indicators. Moreover, different indicators may exhibit cross-reactivity or selectivity towards specific ions or compounds. This selectivity can limit the applicability of indicators in complex sample matrices or when simultaneous determination of multiple analytes is required. Further research and development in the field of visual color indicators can also help improve their performance and address some of the limitations mentioned. Advances in chemical engineering and material science may lead to the development of more sensitive indicators that can detect smaller changes in pH. In addition, efforts can be made to standardize the color and interpretation of indicators, reducing subjectivity and increasing consistency in pH determination. Standardization protocols and guidelines can help minimize variations caused by factors such as lighting conditions and individual perception. It is worth noting that visual color indicators are still widely used and valuable in many applications where precise pH measurements are not crucial. They provide a cost-effective and quick method for obtaining approximate pH values, making them suitable for educational purposes and initial assessments. By taking these steps, users can minimize errors and obtain more accurate pH determinations. Furthermore, it is crucial to recognize that visual color indicators are not suitable for all situations. In cases where precise pH measurements are required, such as in critical laboratory experiments or industrial processes, alternative methods like digital pH meters should be employed. These instruments offer higher accuracy and precision compared to visual color indicators. To overcome the limitations of visual color indicators, ongoing research and development efforts are necessary. Scientists and engineers can explore new materials and chemical formulations to improve the sensitivity and selectivity of indicators. By enhancing their performance, visual color indicators can become more reliable tools for pH determination. Standardization also plays a vital role in mitigating the limitations of visual color indicators. Developing protocols and guidelines for the color and interpretation of indicators can reduce subjectivity and improve consistency in pH determinations. This standardization would provide a more unified approach to pH measurements, allowing for greater comparability between different studies and laboratories. In summary, visual color indicators are widely used for pH determination due to their affordability and ease of use. However, they do have limitations that must be considered. The sensitivity of indicators can be limited, and their accuracy and precision may not match that of digital pH meters. Interference from other substances in the solution can also affect the accuracy of color changes. To overcome these limitations, complementary pH determination techniques and regular calibration are recommended. Research and development efforts can help improve the performance of visual color indicators, and standardization protocols can minimize subjectivity. While visual color indicators are useful in many applications, alternatives should be used when precise pH measurements are required. Overall, understanding the limitations of visual color indicators is important for obtaining reliable pH determinations. In summary, visual color indicators are widely used for pH determination due to their affordability and ease of use. However, they do have limitations that must be considered. The sensitivity of indicators can be limited, and their accuracy and precision may not match that of digital pH meters. Interference from other substances in the solution can also affect the accuracy of color changes. To overcome these limitations, complementary pH determination techniques and regular calibration are recommended. Research and development efforts can help improve the performance of visual color indicators and standardization protocols can minimize subjectivity. While visual color indicators are useful in many applications, alternatives should be used when precise pH measurements are required. Understanding the limitations of visual color indicators is important for obtaining reliable pH determinations. Visual color indicators offer a convenient and accessible method for estimating pH levels in various applications. Despite their advantages, it is essential to acknowledge their limitations to ensure